We learned polynomial division, where we would divide a polynomial by some factor, let's say x minus a. So this was the divisor, this was the dividend. We would get a quotient here. Here we would get this factor x minus a times q of x, which is the quotient, and once we subtract it from here, we would get the remainder. Let's call it that. Now, if let's say we were to divide this polynomial p of x by the factor x minus a, because we are doing that because we want to see whether this is a proper factor of it, or if not, then what is going to be the remainder, right? So do I really need to perform the entire long division every time, or is there a shortcut? Today we are going to show you one of the most powerful shortcuts in P3, a shortcut that eventually leads to, number one, factorization, right? Number two, solving polynomial equations of higher degrees. For quadratic, you already know the quadratic formula, right? And you know how to do the middle term breaking. Number three, partial fractions, right? Which is also used in integration, in differential equations and whatnot, and a huge number of other Cambridge questions. So let's begin. Now, let's revisit the polynomial division that we did in our last lesson. Suppose we are dividing a polynomial, a cubic polynomial, x cubed minus 2x squared minus 5x plus 6. Now, I did it with our regular numbers. For example, 35 divided by 4 is what? It is 4 times 8 is 32. You subtract it from here because the process is the same, right? So now we can rewrite this 35 as 4 times, which is the divisor times the quotient plus the remainder, right? We can rewrite it like this. Hold this thought. We are going to use it later as well. Now let's say we are dividing this polynomial by x minus 2. So this is going to be x squared. This is going to be x cubed minus 2x squared. We subtracted, we added. So this gets cancelled, this gets cancelled. So we get minus 5x plus 6. We do minus 5. So this becomes minus 5x. This becomes plus 6. And then we do this plus. This becomes negative. So 6 minus 10 is negative 4. So I can rewrite this polynomial x cubed minus 2x squared, the dividend which was inside this long division format here inside of this operation. So this can be rewritten as divisor x minus 2 multiplied by the quotient, which is x squared minus 5, and you add the remainder, that is minus 4, right? So now, so make sure that you are so you should always understand this, that the p of x so p of x may be rewritten as divisor multiplied by the quotient plus the remainder. Okay, so any polynomial may be represented like this. Now, so this identity is everything, and do not move on. Maybe you want to go just pull the cursor back and replay this part, but do not move on until this line makes sense, because today's entire lecture is going to be built on this. Now watch carefully. Let's say that a polynomial p of x may be rewritten as, or may be represented by x minus 2, some linear factor, times some other factor q of x. Let's say that this is a quotient and this is leaving a remainder of 4, or let's not call this minus 4 a remainder. Now I want to know the remainder. I'm not calling this negative 4 a remainder. I am proving it that this is going to be the remainder. So I don't want to know the quotient, just the remainder. What value should I substitute for x? So that's pretty straightforward. You would tell me that we can make this a 0, and we can make this a 0 by taking this bracket x minus 2 and equating it to 0 in order to get a value of x is equal to 2. Now let's put 2 as an input in this polynomial. So we get 2 minus 2 times q of 2 and then negative 4. So 2 minus 2 becomes 0. So 0 multiplied by anything becomes 0. So this is now 0 minus 4 is equal to p of 2. So what we have obtained is that when I put the input 2, I got a remainder of negative 4, right? Now, This is very interesting. Notice what happened. The quotient disappeared. As you could see that this did not exist here. So this disappeared. The entire divisor disappeared because this became a 0, right? 2 minus 2. And only the remainder survived, which means that the remainder when dividing by x minus 2. So if you were to divide this p of x by x minus 2, so you would get some quotient here, and this is going to become x minus 2 times q of x, and once we are going to subtract it, we are going to get a remainder which turned out to be a negative 4. Now this, so when you were dividing this polynomial by x minus 2, you obtained a remainder of 2, and this is called the remainder theorem. Now let's state the remainder theorem properly. It states that if a polynomial p of x is going to be divided by x minus a, the remainder that you are going to obtain here, let's say the quotient is q of x, so this is going to be x minus a times q of x, and once you subtract it, the remainder that you get here is actually p of a. And where does this a come from? It comes from when you equate the divisor to 0 in order to get x is equal to a. So this is the remainder factor theorem. Now this is the remainder theorem. Now it is so not because Cambridge says so or it is written in your book, but it is because it is a because the divisor becomes 0. Can you see? And when, because we did this multiple times at the start and in the last lesson as well, that this p of x may be clearly represented by x minus a factor which we are dividing it by, times the quotient, right? And then you add the remainder to it, right? So if this becomes 0, so if this becomes 0, then clearly, and this is going to become 0 when you take x as a. So p of a is going to be a minus a, which is 0, 0 plus r of a. So remainder, so this remainder is nothing but p of a, right? Now let's do an example. Let's say that you have p of x is equal to a cubic polynomial 2x cubed minus x squared plus 4x minus 7. Let's divide it by x minus 3. Okay, now when I divide it by x minus 3, so this becomes I multiplied by x squared, because remember, how do we do it? We divide this term by this in order to get this, right? So you know it already. Now this becomes, so this is now, I multiplied by 2x squared. So this becomes 2x cubed minus 6x squared. Now we are going to do it quickly. This gets subtracted, this gets added. So this is 5x squared. This gets copied down plus 4x. And now I divide this 5x squared by x in order to get the next term in the quotient, which is going to be, let's change color. So that's going to be plus 5x. I don't know where this arrow comes from. So this becomes 5x squared minus 15x. Now I change the signs, which is extremely important. So this gets cancelled. 5 plus 14, 15 plus 4 is 19, 19x. This negative 7 gets copied down. And then I multiply by 9. So this becomes 19x minus 27. This gets added. So the remainder is 20. Right? Now I can rewrite this polynomial, this cubic polynomial 2x cubed minus x squared plus 4x minus 7 as a product and sum. So a product of the divisor x minus 3 times the quotient, which was 2x squared plus 5x plus 9 and plus 20, which is the remainder. So this is the divisor, this is the quotient, and this is the remainder, and this is a composition for our polynomial. Now our remainder is simply 20. Now what would have done if I just make this bracket a 0? So I am going to put x is equal to 3, and I can put x is equal to 3 here as well. So this becomes 2 times 3 cubed, which is 27, minus 3 squared plus 4 times 3 is 12 minus 7. This becomes 0, and this becomes, and whatever this becomes, it doesn't matter, because 0 multiplied by whatever, I will write whatever, becomes a 0, right? Plus 20. So this here is 20. And when I put x is equal to 3 here, so this becomes 54 minus 9 plus 12 minus 7. So Okay, I think we may have made a mistake here. So 3 cube is indeed 27. So 27 times 2 is 54. 54 minus 9 is 45. 45 plus 12 is 57 minus 7 is 50. So this, I must get a 50 here, and I don't know why am I not. Oh, 3. Oh, sorry. So I could see here. So this is a plus 19. My bad. So this is a plus 19. So 3 times 19 is 57. So this was a 57. So 57 minus 7 is 50. So this here is 50. And this is a 50. My bad. I'm sorry. I made a mistake. You guys may have spotted it earlier than I did. So yeah. Now you can see that when the polynomial was divided by x minus 3, it gave me the same result, so the same remainder as p of 3, and 3 was obtained when I equated the divisor by 0. Okay, therefore this is done and no division would be needed. So if in exam you're asked to find the remainder, if this polynomial was divided by x minus 3, all you need to do is you just find this, and this is the shortcut, and you're going to save 5 minutes. Okay, now we are going to discuss a sign mistake that always kills marks in exam. Now let's address this thing that you guys always get wrong, the student community, most of them, I would say. Suppose the question says that the remainder when px, a polynomial, is divided by x plus 1, it produces a remainder of 2. So you will quickly do that p of negative, p of negative 1 is equal to negative 2, right? Sorry, the remainder is 2. So you would do this, right? Now let's prove it, right? So px, so I can rewrite this p of x as divisor, which is x plus 1, times some quotient plus a remainder, right? Plus a remainder. Now when I put p of negative 1 here, so this becomes p of negative 1, right? So this becomes 1 minus 1 is 0, right? Negative 1 plus 1, basically. Negative 1 plus 1 is 0 times q of negative 1 doesn't matter plus remainder. So this entire thing becomes 0. So I am just left with a remainder on the right hand side, and this is p of negative 1. So p of negative 1 therefore is the remainder, and we were told that the remainder is 2. So we would say that when this polynomial p of x is divided by x plus 1, it produces a remainder of 2. So that's, here's the proof. Okay, now we don't need to really memorize this. This is pure logic. So whenever you see x plus 1, always think x is equal to minus 1. So if this is the divisor, then you are going to do p of negative 1. If the divisor is x plus 2, you are going to do p of negative 2. If the divisor is x minus 5, you are going to do p of 5. Because so you always make the bracket 0. So this bracket has to become 0, and these are the values that you obtain for x, or the input, whenever you are trying to make the divisor 0. Now let's take the remainder theorem one step further. Suppose that when you put, so when you are dividing p of x by x minus 2, it produces a remainder of 0. Now, so this is p of x. When divided by x minus 2, excuse me for my writing, it's pretty bad, I know. Now, what does this mean? This means that p of 2 is going to be equal to 0. Now, what does this mean? It means the remainder when divided by x minus 2, that is divided by x minus 2. So there's going to be a certain quotient, and here you are going to multiply this divisor by a certain quotient, and you are going to subtract it. I'll put a glaring red here. When you are going to do that, you are going to find a remainder, and they're saying that the remainder is going to be 0. So how we can represent p of x as is that we multiply the divisor and the quotient, and and we add the remainder to it, and the remainder we know is just 0. So we are just going to put nothing here. Now what does this mean? This means that now when you're dividing, so let me divide both the sides by x minus 2. So what do I get? I get p of x divided by x minus 2 is nothing but a quotient without any remainder. So this division works perfectly, no leftovers, therefore x minus 2 must be a factor. Now we will say x minus 2 is a perfect factor, or a factor is one and the same thing, is a factor of p of x if or rather, let me write down, because it's a factor theorem. So x minus a is a factor of p of x if p of a produces a remainder of 0. Okay, that is all that the theorem says. Factor theorem is simply remainder theorem times remainder equals 0. That's it. Okay. Now, moment of truth, right? Let's tackle a few exam questions. Let's say that p of x is equal to ax cubed, where a is an unknown constant, plus 5x squared minus 4x plus a constant b, right? Now, let's say that we are given that x plus 2 is, now these are the given conditions. So given x plus 2 is a factor, which means what? That p of negative 2 is going to be equal to 0. It's producing a remainder of 0. Now, so this is the first condition. The second condition, let's say, is that when you divide this polynomial p of x by x plus 1, it produces a remainder of 2. So now what does this mean? This means that p of negative 1 is going to be 2, right? So now, using the factor theorem, we can quickly plug in the two values. So p of negative 2, I will put that here. So this is going to be 0. So p of negative 2 cube is negative 8. So this is negative 8a. Negative 2 square is 4. 4 times 5 is 20. Negative 4 times negative 2 is plus 8. And plus b here. So b is going to be equal to 8a minus 28. So that's our first equation. And you would remember that we did exactly the same question in our last lesson as well. Now, the second equation is going to be from here. So this is going to be p of negative 1. So p of negative 1 is 2. And when I put negative 1 in this function as an input, so this becomes negative a plus 5 plus 4 plus b. So this is going to become b minus a is equal to negative 7, or rather a is equal to b plus 7, or rather b is equal to a minus 7, right? A minus 7, and b was 8a minus 28. So 8a minus 28 is equal to a minus 7, and we can take it there. So 7a is equal to 21, or a is equal to 3, and when a is equal to 3, b is going to be negative 4, and that's it. You have congratulations, you have obtained 4 marks in your P3 exam. Now, this is as simple as that. So we have applied both the conditions, we have solved the two equations simultaneously, and we obtained the values of a as 3 and b as minus 4. Finished. Notice something: no division, no long method, just good understanding of the topic. Now, here's the important question. Why are we spending so much time in finding factors? Because our next topic is going to be partial fractions. That's the reason, right? And partial fractions begins with factorizing denominators. For example, if you have 1 upon x squared minus 5x plus 6. So before we can decompose this into something 1 upon some linear factor plus b upon something other linear factor, let's say we must first factorize it, right? So we know that 3 and 2 are the roots of it. So x minus 3, x minus 2 would be a factor. So using everything we have learned today, so our today's lecture is not going to be isolated, because see, you can do this very easily. However, if you're asked to do this, a cubic polynomial x cubed plus 2x squared minus 5x plus 8, you need to find the 3 factors, right? So that's important. So today's lecture is not really isolated. It is preparing you for the next 2 lectures, which are going to be on partial fraction 1 and 2, right? So what are today's takeaway? So polynomial division created the idea, which we did in our last lesson. Polynomial division, or long division as we call it, it created the idea, and then we used the remainder theorem to remove the division, right? It removed the division. You may want to take these down just for recapping purpose and to find the distinction in all these theorems. Factor theorem removed even more work, because when the remainder is 0, it becomes a factor theorem, because it proves that the divisor is an actual factor of the polynomial. A factor exists only when the remainder becomes 0. So p of a, x minus a is a factor of p of a, is a factor of pa if and only if this is p of x, if and only if p of a is 0, right? So that's factor theorem. This entire topic is preparing us for partial fractions. So in the next lesson, which is probably going to be tomorrow or day after, perhaps on Tuesday only, we are going to cover partial fractions 1. And you'll finally see why finding factors is so important in Pure 3, because that's going to get linked with integration, with differential equations, and even with quite a few topics. So even if you're not enrolled with us in Easy Taleem, you should follow the series. You should follow this channel, subscribe to the channel, and also follow us on our Instagram. We go by the name of Easy Taleem. So our handle is EASYTALEM. And if you have any other queries that you want to get resolved, no matter wherever you are from across the globe, for mathematics, you can reach out to me on my WhatsApp 03293028485. But be patient, because there are quite a few queries. I'm Sir Irfan, this is Easy Taleem, and we are going to stay connected for the October-November 2026 retake series.